Vanakkam. Welcome to this video on biomechanics. In this video, we will continue our discussion on introductory mechanics, on statics and dynamics. So, in this video, we will discuss about the various types of joints in the human body. Okay. One type of joint in the human body that is easy to observe is the hinge joint. Hinge joint, in this case, this joint can move either can rotate either in this direction or in that direction. That is, it has a single degree of freedom. For example, the elbow joint. Right? This flexion of the forearm, this flexion and the extension happens. It's a single degree of freedom. Well, actually, this movement also happens, but that's not fully a elbow joint movement. Okay, so that is outside the scope of this discussion. Here we are discussing this. Right? It's a single degree of freedom joint, a hinge joint. It has 1 degree of freedom. The example is the elbow joint. Okay. Then you have these saddle joints. It's a very special type of joint. You call this as a saddle because it resembles the saddle of a horse rider, right? So, this person can either go front or back, the anterior posterior direction, or left or right in the mediolateral direction. So, there are 2 movements that are possible, and at any given point in time the net movement is a function of these 2 movements as vectors, something that is easy to say but somewhat difficult to visualize. So, how many degrees of freedom does this have? Obviously, there are 2 degrees of freedom because there is the anterior posterior movement and there is the mediolateral movement. So, there are 2 degrees of freedom. The example is the thumb metacarpal joint. That happens between the trapezium bone and the first metacarpal. Right. That is, the thumb can either make that movement or it can make that movement. But then at any given point in time, if the thumb is doing that, for example, is a combination of these 2 movements. So, how much each of this movement has contributed to the net inclination of the thumb, it is not very easy to model. You have to take it from me when I say this, because I work extensively in hand function. Specifically, we have now begun working on kinematics of hand function, and something that we had great difficulty in modeling and understanding was this particular movement of the thumb, right? Difficult to model. Then you have the ball and socket joint. Example of the ball and socket joint. Of course, this has 3 degrees of freedom. Example of the ball and socket joint is the shoulder joint and the hip joint. Okay. So, that means this ball can rotate in any of the 3 axes, but cannot translate. There is no translation possible, but there are 3 possible rotations. Okay. So, an expectation is that because there is no translation possible, there will be a great amount of stability that can be ensured, but the amount of rotations that are possible, especially in the shoulder, is so huge that you are not able to have a great amount of stability. which is why frequently you have dislocations of the shoulder joint, and it is a serious problem. Then you have the pivot joint. This is the case where the rotation happens about this pivot, right, this rotation. So, that is the rotation that is possible, right. Number of degrees of freedom is 1, and this is what is seen in the neck joint, for example, like that I can move like this. This is of course possible through the pivot joint in the atlantoaxial joint. This is the joint between the atlas and the axis, okay, atlantoaxial joint in the neck, the pivot joint. Okay. So, the number of degrees of freedom varies, the amount of movement increases, and different types of these joints give rise to different amounts of movements within the available degrees of freedom. So, it is not just the number of degrees of freedom, but it is also the amount of movement that is possible, right. So, or the range of motion that is possible. Okay. Some examples. So, at the neck you have the atlantoaxial joint, which is a pivot joint, the shoulder is a ball and socket joint, the elbow is a hinge joint, then you have the CMC joint, right, which is a saddle joint, like this person who is sitting on a saddle, is a horse rider sitting on a saddle, he can go to his left or right depending on the movement of the horse, or to the front or the back. So, there are 2 degrees of freedom that are possible. Then you have a nearly perfect hinge joint in the knee, and a plane joint in the ankle, okay. And of course, the hip joint is a ball and socket joint, and then you have the wrist joint, which is an ellipsoid joint, as is the metacarpophalangeal joint, because the wrist joint I can make that movement, or I can perform radial and ulnar deviations. I can perform ulnar deviation or radial deviation. I can also flex and extend an ellipsoid joint. As with the fingers, I can flex or extend the metacarpophalangeal joint. I can also abduct or adduct. Remember, abduction, adduction of the wrist is not called abduction, adduction, but rather as radial and ulnar deviation of the wrist. Okay, but for the finger, that movement is possible. This sideways movement is possible. It is called abduction, adduction of the metacarpophalangeal joint. It's an ellipsoid joint. Okay, this is the wrist that is marked here. Okay, this is the neck or the atlantoaxial joint. Of course, this is the shoulder, this is the elbow, this is the thumb metacarpal joint, the joint between the trapezium and the first metacarpal. This is the hip, and this plane joint is the ankle joint. Okay. Some others we are not discussing, just to leave as an exercise for you to check, do check this. So, one more is the hinge joint in the proximal interphalangeal joint and the distal interphalangeal joint of the fingers. For example, this movement is the proximal interphalangeal joint movement, and that movement is the distal interphalangeal joint movement. These are modeled as hinge joint because there is only 1 degree of freedom that is possible, either flexion or extension. Then I have that movement that is possible for the metacarpophalangeal joint, either flexion, extension, or abduction, adduction, or a complicated movement like this, which can be modeled as a sum of these 2 movements. Right. And this is an ellipsoid joint. Remember, the MCP joint is an ellipsoid joint, whereas the distal interphalangeal joint and the proximal interphalangeal joint are hinge joints. The MCP joint is a ellipsoid joint, whereas for the thumb the CMC joint is a saddle joint. Okay. So, in this video we looked at the various types of joints within the human body. We looked at the joint in the neck, which is a pivot joint. Then we looked at the elbow joint, which is a hinge joint. We looked at the shoulder joint, which is a ball and socket joint. We looked at the wrist joint, which is an ellipsoid joint, and the metacarpophalangeal joint, which is an ellipsoid joint. The carpometacarpal joint of the thumb is a saddle joint. The knee joint is a hinge joint. The ankle joint is a plane joint. The hip joint is a ball and socket joint. We looked at all these joints in the human body. With this, we come to the end of this video. Thank you very much for your attention.